Okay, hello. Grade 11, grade 11, grade 11, grade 11, grade 11, grade 11. Or let me say future grade 11s, aspiring grade 11s to be grade 11s to come. Mako maswigi. What is the state of the group? No, Musa Changas, we're not doing integers. What are you talking about? You guys, grade 11, are not, you're not integer people anymore. Right, we're doing exponents. Remember, we started with exponents yesterday, so we are continuing with exponents. But before we jump into the continuation of exponents, oh, thank you very much. Hey, I was thinking to myself, what in the world? How can you say integers, exponents? Oh, Sage, is that so? Oh, maybe you guys can tell me more about that. What are you guys? What's cracking in the group? What's happening? You can share specifics. I love that you guys are saying you are learning in the group. You are working together. That's beautiful. 107 members. My goodness, Makoma, what in the world? It's like you're starting starting a movement there. Starting a movement. Yeah, that's insane. That's a crazy number. That's a crazy number. So you're trying to tell me that there are 107 grade 11 learners that are actually have the mindset of you managed to pull people, that's for sure. Yes, we're still doing exponents and surds. We are actually, yeah, we're gonna move in that sphere. All right. So I hear Sage says to me, we are still doing exponents and surds. You guys are helping each other in the group. You are learning in the group. You are working together. Maybe I just wanted to know what are you guys doing specifically. Yeah, I see, Makom. I see. Yeah, we're still trying, Master. Yeah. You guys need to master. You need to master these exponents. You need to master them. You need to master them. Oh, okay, good. You are sharing PDFs and treating questions that appear difficult. That's good. Someone sends a question and others attempt. That's good. Wow, I love the synergy. You guys know that part of I think is it the 21st century skills, one of the most important skill that we need to be inculcating within the education system is the skill of collaboration, collaborative work, working together, sharing of ideas, working together to improve one another. So you guys are actually practically applying that collaborative skill. You guys are coming from different parts of the country, but you guys are helping each other in a collaborative sense. It also helps that we have 8 students in the group. Oh, nice. That's beautiful. Okay. I think you guys are actually now in this trail of thought that I think I need grade 11s to be in. So I don't, when I'm in the school environment and I'm teaching grade 11s, I don't baby grade 11s. You guys are at the brink of going to grade 12 and at the close and conclusion of your high school career. So that being the case, babying grade 11s is not something that I do. Rather, I encourage grade 11s to be people that work independently and collaboratively. You guys need to learn to be people that don't depend too much on the teacher, but you learn to depend on yourself and in each other. Chenza says, I'm an A student, but not in the group. Then Chenza, you need to get yourself in the group, Kaloku, so that you can share your expertise there. Stop crying. Wipe those tears and get in the group. Yeah, I have not yet showed anything. So far, it's still black. There's no words or anything like that. You shouldn't be seeing anything. You should be hearing my voice. Queen Sokudela, are you close? What do you think? That is funny. That is so funny. You guys are hilarious. What do you think? All right. So when I posted the exercises that I wanted the grade 11s to do, I posted a lot of them. All right, posted a lot of exercises. The exercises that I posted. Oh, I see. No, it's very important. I am closer. He said Kaloko. That's fine. So the exercises that I have posted on the TikTok page, the slides, all right, there are 4 questions that I wanted basically us to do based on what we covered yesterday, all right. So it's the first 4 questions. So in the slides that I shared with you, it's only the first 4 questions from, I think, the first 4 slides that you have on that particular slideshow. All right, and I'm just hoping that we can just do these, all right, step by step, whilst obviously recapping on what we did yesterday. All right, because you will remember that yesterday when we started out with exponents, we did this example. All right, we did this example, and this example, it basically was helping us. This is grade 11 for those who are joining in. This example, when we did it, we basically looked at a few steps that are important whenever we are dealing with multiplication and division of numerical base exponents. When our bases are numerical values, all right? And we said that first step, we need to convert all the composite bases to prime bases, all right? Meaning when we change those composite bases to prime bases, we need to make sure that we put them in brackets. And you remember that we changed the 8 to 2 to the power 3, then we put it in brackets, and then we had the exponent x minus 1 on the outside. We did the same. Here we saw that the prime base is already there. 3 is already a prime number, so we retain that prime base. It's already raised to the power negative x minus 1. Then that 1 over 4, you'll remember I said 1 over 4, we change 1 over 4 to 1 over 2 to the power 2, but then that 1 over 2 to the power 2 can be expressed as a negative exponent where the base is 2, meaning simply that this 2 moves from the denominator to the numerator. It assumes the numerator position. Then the exponent 2 changes from positive to what? To negative 2. And we write it as 2 to the power negative 2. All right? And that's why 1 over 4 is replaced by 2 to the power negative 2, with 2 being a prime base. 6 changes to 2 times 3. Then the x minus 3 is on the outside. 9 changes to 3 to the power 2. And then we have the exponent 1 minus x on the outside. Then after we change convert composite bases to prime bases, all right, and we put it in brackets. The next step is to do what? To apply law number 3 of exponents. We then apply the distributive law for the exponents. And by that we mean this 3 needs to be distributed to the binomial expression x minus 1. 3 times x is 3x. 3 times negative 1, negative 3. And we must make sure that the 3 gets distributed to both terms, not just to x alone. All right. Here we are fine. Here we distribute negative 2 to the negative x, we get positive 2x. Here, remember 2 has an exponent 1. We don't usually obviously reveal that 1, but we must know that it's always there. That 3 has an exponent 1. It's always there, even if we don't see it. Then what we do is we take each respective base with its exponent and we distribute. 1 times x gives us x. 1 times negative 3 gives us negative 3. That's base 2 with x minus 3 with it in it. Then we take this base 3, we do the same thing. The 1 times x gives us x. The 1 times negative 3 gives us negative 3. Then we have 3 to the power x minus 3. Then we do the same thing with this 3 to the power 2. We distribute the 2 to the 1, distribute the 2 to the negative x by multiplication. 2 times 1 is 2. 2 times negative x is negative 2x. Then after we are done with the application of law number 3 and applying the distributive law, we must then collect the same bases and apply law number 1 and 2. What does law number 1 say? When bases are the same, we are multiplying, we must add the exponents. What does law number 2 say? When the bases are the same and we are dividing, we subtract the exponents. So if we collect, look at the bases that we have here. We have base 2, base 3 in the numerator. In the denominator, base 2, base 2, base 3, and base 3. So the only bases that we have are 2 and 3. So that means we need to collect first 2. And then after that, we need to collect 3. So let's start with base 2. We have base 2, and base 2 to the power 3x minus 3 is in the numerator. So let's first write that down. 2 to the power 3x minus 3. That's base 2 to the power 3x minus 3. That was that. Stays the same, nothing changes. There's no other base 2 in the numerator, so we turn our attention to the denominator. We go here. Oh, there's another base 2 in the denominator. The exponent is 2x. So what do we do? Since this base 2 and this base 2 is in the numerator, this one is in the denominator, we apply law number 2, which says when the bases are the same and we are dividing, what do we do to the exponents? We subtract them. So that will mean that 2 to the power 3x minus 3, which is that there, has to be then subtracted. Subtract 2x, because this is in the denominator. So we are subtracting. So the signs in the denominator will change whenever they move to the numerator. 2x becomes negative 2x. Let's go to this base. 2 to the power x minus 3. This x is in the denominator. When it moves up, it becomes negative x. When minus 3 moves up, it becomes positive 3. That's applying law number 2, because when these move up, applying law number 2, 2x changes to negative 2x, x changes to negative x, minus 3 changes to positive 3. So hopefully we all understand what base 2 and the collection of its exponents, applying law number 2, how it affects the exponents. So base 2, we are covered. Then we move on to our next base when the base 2 is complete. We move on to our next base, base 3. Base 3 has the exponent negative x and negative 1. That's already there. But then if we go to the denominator, we have base 3 raised to the power x minus 3. We apply law number 2. When we move these up, what happens to the x? It becomes negative x. What happens to the negative 3? It becomes positive 3. See? Moving on, this is another base 3. This 2 becomes negative 2. This minus 2x becomes positive 2x. And then what do we do after that? We add and subtract like terms. After collecting the bases with their respective exponents, applying law number 1 and 2, we then add and subtract the like terms of the exponents. So let's do that. What's 3x minus 2x? X. What's x minus x? 0. So we have 2 to the power 0. Then we move on to the constant terms. The terms without variables. Minus 3 plus 3 gives us another 0. So 0 plus 0 gives us 2 to the power 0. What about with base 3? Negative x minus x gives us negative 2x. What's negative 2x plus 2x? It gives us 0. Then the same thing with the constant terms. Minus 1 plus 3 is plus 2, and 2 minus 2 gives us another 0. What's 0 plus 0? 0. What's 2 to the power 0? 1. The dot means multiply. What's 3 to the power 0? 1. What's 1 times 1? The answer is 1. So all in all, we were able to simplify this to get the answer 1 by following these basic steps. Convert all composite bases to prime bases, putting in brackets what we change. 2, applying the distributive law, law number 3. 3, collecting same bases by applying law number 1 and 2. 4, add and subtract the like terms. 5, apply exponents law, simplify, and then get the answer. Okay. So this all in all, guys, is how we simplify exponents that have numerical bases where there's multiplication and division involved only. Okay? This is how we simplify when there's multiplication and division only. NK, nothing makes grade 11 so hard. The one primary thing that makes grade 11 very hard is a stubborn mind or attitude of a learner that believes that they are now in grade 11 and therefore it is hard. No one can convince you to believe otherwise. If you believe that, then, you have basically defeated the whole purpose of what we're trying to do. So, mindset. We need to first establish a very good mindset that it is not hard, it is possible, it is doable, and then we can work from there. So as slowly but surely as you can see this is not difficult. This is very easy. And in actual fact, what happens is that the more you practice and the more you apply the approach and you apply it consistently, then you will see that, it's nothing. Women of faith, I hope, I don't know if you're joining in for the first time, but if you are and you're saying you want to screenshot, I'm guessing you want to screenshot because you're probably joining for the first time. This was me recapping on a problem that we had covered yesterday, all right? And this is obviously a grade 10 problem. It's not a grade 11 problem, but in grade 11, we revise this grade 10 approach of simplifying, obviously, exponents that have numerical bases where there's multiplication and division. It's very important. Okay, so I'm now going to go and turn our attention to the homework that we're supposed to do. And I'm only just going to focus on the problems that I said were important for us as far as what we are doing now. NK, should I start studying for grade 11 now? I want you to answer that question yourself. Maybe you can comment in the comment section and let me know what you think. All right. Yeah. All right. I had the privilege some years ago to work with I was privileged to actually be mentored by this other guy. Yeah, Makoma, we had homework. You guys didn't know you had homework? Oh my soul, you guys are funny. I was privileged to be mentored by this guy from the States, and I remember him saying something that has never left me. He said, if you do what you've always done, you'll get what you've always got. I'm glad you did it, Angelique. Good job. If you do what you've always done, you will get what you've always got. If you're wondering why am I not getting the very good marks, all right, then like I said, if you're doing what you've always done, you will get what you've always got. Okay. So I think now what I'm going to do, since you guys didn't even know about the homework, now that gives me even more reason to actually be part of this group of yours. So Makoma, you must make sure you get my number before the night is through, but I will not write it here in the group. You will actually get it from me privately. Please then make sure you add me in that group of yours that you have on WhatsApp, and then whenever the specific homework that I want to be done, I will actually even share it in that group so that you guys know that it is kind of official, right? Please don't take it like it's homework, because I think the mindset with homework is like, oh, there we go again, all right? And I think you guys have already in your minds attached homework to this thing that Surds or ma'ams ask us to do, and I mean, we really don't want to do it, but they ask us to do it anyways. Please look at it in this way. You guys need to, when you've learned something, you need to get your mind and your body behind what you've learned. If you want your mind and your body to become part of what you've learned and you want to own it, the only way that you can do it is by doing exercises related to what you've learned. So we need to take it as such. We want to master the maths. We want to be able to even do it in our sleep. We want to be able to wake up. You want me to come at 3 a.m. in the morning and wake you up and be like, here's a problem, do it, and you being able to unflinchingly do it without even consulting a textbook, because it's so part of you. So take it like that. The exercises are not homework, they are tools to help you master the content. If you want complete mastery and you want complete internalization of concepts, then you need to do it. Okay, sorry, I had to just go and hush some kids here. Okay, so here's the problem then. And so let's try and do this then. This was the first problem. 2 to the power x times 12 to the power x minus 1 times 3 to the power 2x over 6 to the power 3x minus 1. So 1, 2, 3, 4. Can we please do this? These 4 problems. Okay. I think it's not going to stop this teaching. All right, so first and foremost, what we do, we said step number 1, we change composite bases. Oh, you're busy with number 1, Magoma. Okay. All right. Can I just get an indication that people are busy so that I don't probably jump in and do it in your stead? All right. I'd like to give you guys an opportunity to do these. Okay, we're busy. Okay, good. All right. Women of faith seems like they're busy. All right. Thank you, Ketsa, for answering that question. Busy in number 1, done with number 1, Abu. The China hate. I think Mr. The China hate usually is just a person who likes China hate himself. You trying to hate on us doing maths? Okay, so 4 minutes, guys. Okay, these are 4-minute problems. 4. Yeah, well, 4, 8, 12, 16. So you should be done in 16 minutes. with all 4 problems. Given January is like, I'm done with number 1 and 2, that's fine, that's good. Okay, let's go on, let's do all 4. Yeah, then relax, try not hate. And can I just suggest as well, relax, and then you can just, I think you can use your finger, you swipe up, it will move you to the next live video, and then you can relax. And Sammy, you can do the same as well. You can relax. It's very important to relax. They try not hate, that's okay. That does not change the fact that I'll definitely be also teaching you just before your exams, no problem. But I'm also doing this as well for those that want to do it. So, like I said, you can just make sure that you can scroll through. Like I think when you scroll, if you actually like swipe up, it will move you to the next live session for maybe another live session where you can sort of like maybe have watch someone else, maybe play I think they play matches and stuff as well, or they have like conversations on TikTok and all of those things. You're more than welcome to do that. Yes, they try not hate. I'm a maths teacher. Yeah. Thank you, Ten Rosh. I think Ten Rosh has said it nice. If we are not forcing anyone, if you guys don't want to learn, leave us. And leave us in peace, please. Or you can join the revolution they try not hate. You are more than welcome to join the revolution if you want. Hi, Refilwe. Hello. For those who are joining in and are like wondering, what grade is this? It's grade 11, okay? We're doing grade 11 maths. Wow, you are at the third question. Very good, that's nice. Refilwe Kodi, say, how are you? I'm doing great, thank you. We're doing amazing here. I hope you're doing well as well. Makoma is done with number 1, very good. I love the pace that we're doing. If you guys, if all of you by now are done with number 1, then your pace is good. Hopefully you are in number 2 now and you're doing that. Okay, that's good too. Scabby, I will be explaining the questions shortly after the time that I've allocated, 4, 8, 12, 16. After 16 minutes is done, then I'm going to say thank you so much, and then I will explain all 4 questions. I think that's what I'll be doing just for today, all right? Then we'll continue and pick up on the next concept that I wanted to cover on exponents tomorrow, okay? So these 4 questions will basically make the bulk of what I want to cover for today, and then we'll move on. Remember, we're starting very early, right? Okay. And please, people, I think what's important here is getting to a place where you master the concept, okay? So, for instance, let me share this at the end of the session, not now. I want to share something with you guys. And maybe I'll even share a voice note with you guys, those grade 11 learners in the group. The minute I join that group, there's a voice note I want to share with you guys, coming from one of my learners that's actually currently, it's going to grade 12 next year. But this is a learner that actually did this thing of self-study during the holidays. So her entire December and January holiday break, she dedicated a portion of her time every day to mathematics. And what an impact it had on her performance during the course of the year. She ended the year on an ultimate high. Oh man, I have some amazing students. I love them. Yeah, that's fine, Scabby. I get that. You're asking, let's see, Scabby, what did you ask above? Just trying to get back to your question. Scabby, say if there's a question you didn't understand, how can we get you to explain it more? Oh. Yeah. So like I said, I will explain these questions shortly after the 16 minutes is done. If you, let's say for instance, you weren't able to do all of the questions, all four of them, um, then that's okay, right? Yeah, I think that's another thing with practice. Slowly but surely, you actually get better at answering questions, and even the the the, the time that you spend answering a question, you improve the rate at which you are able to answer questions, all right, and the time rate that you spend. Yeah. So it gets better with time. So be patient with yourself. It's okay. I mean, I understand that we're not all sort of like fast and all of that stuff. I'm not a fast learner myself, actually, you know, um, and I'm not fast at writing. Okay, I'm a very slow learner myself. I need sort of like the thorough, slow explanation. Okay, so yeah. Also, Scabby, you're more than welcome to just maybe send me a message on the side, on the DMs, and yeah, just let me know what your specific sort of like challenge is, if there is any. Okay. Yes, you can. You can. Can I ask, perhaps also, ask you to please go through a certain question? Yes, you can. You can. All right. So some of us are currently busy. Those who are joining in for the first time, we're currently busy answering question 1, 2, 3, and 4, because this was a homework that we're supposed to have done. So we are actually going through and answering these questions. So in your own space where you're at, you are answering the questions. You are attempting to answer the questions. Obviously, this will be of benefit to those that had the chance to join the session that I did yesterday. But if you haven't, you can go onto the YouTube channel, Maths is a Game. You can watch the session if you want to, okay? And then also there's a group that these kids, these amazing grade 11 students have actually started as well. So that group I'll be joining soon as well, be part of that, okay? Kamo, Zizo, that's fine. You finished all 4, that's amazing, that's great. This is, obviously, like I said, this is a revision of grade 10, all right? So this is not grade 11 exclusively, but it's something that we are required to actually do before we go into some of the detail that is in the grade 11 syllabus, okay? So we actually expected to first do the grade 10 and cover the basis of the grade 10 syllabus, so that we can start on a very solid, base and understanding, okay? Mammon, who's Mammon? Mammn. Trade. Trade 11. It's trade 11. I don't know if that's supposed to be is that a deliberate error? Is that like a error that was genuine? Trade what? What trade is this? Oh, okay. 2 to the power 5 times 6 to the power of 7. This bracket to the power of 3. Done, everybody's done. Okay, so let's at least do the first one. And you'll just have to excuse the little voices that you hear in the background. I have little ones that tend to really be very vocal at this time of the night, so just bear with that. Hopefully it's not too much, but it does tend to be too much. If it is, just let me know so that I can actually quiet them down a bit. But very active beings. So 2 to the power ax. So remember, first step, we convert. First and foremost, let's look at this. We can see that 2 is a numerical base, multiplied by 12, that's a numerical base, multiplied by 3, that's a numerical base, all over 6, that's a numerical base. So the relationship between these bases is one of multiply and divide. So if the relationship is multiply and divide, then it means step number 1, we need to first convert all composite bases to prime bases. Just hang on, sorry guys, this is getting too much. So we convert all composite bases to prime bases. No, that's fine, enclosed. You can finish off those. It's fine. You can finish off those, all right? Remember, I said just the first 4, all right? If you're doing these ones as well, then I mean, that's fine, but the first 4 were the fundamental ones, okay? Okay, so convert all composite to prime. 2 is already prime, so there's no need for change there. 12, if you take 12, you write in your calculator 12, and then you press equal to, then you press shift, then you press fact. That will help you convert the composite base to a prime base. Okay. Hey, can you please give us at least 5 minutes? Okay, I think let me give the 5 minutes that Musa is asking for so that there's not too much crying that happens. Okay, let me give 5 minutes extra additional. Then I'll do it after 5 minutes. Sorry about that, guys. Let me give you that time. So that means at 9:25, I will then continue. Never knew that on high school, the shift and fact thing. Aibo, kamozizo kandi, what's happening? You were struggling, so that means you're no longer in high school. Where are you? Ukamozizo is joining in, but he's not in high school anymore. Where you at, bruh? Are you in varsity now? Because if you're saying in high school, that means you're no longer in high school. Are you just joining in the math session for the fun of it? Makoma Musa, I didn't. I did till number 3. My mom called me and I had to stop. Yeah, please don't become rebellious kids at home, because of joining in these sessions, please. Oh, Kamozo, you want to upgrade your marks? Oh, I see. So what does that mean? Does that mean you are actually at a school where you are upgrading? And are you upgrading as a grade 12 learner? Or have you gone back to an actual school and you are actually doing grade 11 from scratch again and then moving on to grade 12? So what's the deal? I'm 7 hours away from home and I don't have a calculator. No, that's fine. That's fine. So remember, changing composite bases to prime doesn't necessarily need to you having a calculator. That's the whole point, Kaloku Ditabogo. That's the whole point, is to actually finish the first term syllabus before you guys start term 1. So that means we need to consistently have sessions on a daily basis so that we can slowly but surely get the syllabus, completed for grade 11 term 1. So even if we don't finish the entire syllabus of term 1 before term 1 actually begins for next year, but we will have covered a lot of the grade 11 syllabus already. Does that make sense? So hopefully we'll be able to cover a lot of ground before you guys actually begin term 1. So by the time you begin term 1 at school, you'll have covered a lot of ground of the term 1 syllabus already. Okay? And continue. Remember, these sessions will continue even after you guys begin with school. I know that your guys' schedule won't be the same. So then hopefully we can actually acclimatize to a common schedule. I'll also be busy, but we'll see how we'll work around that. But at least for now, okay, we'll take it one step at a time. All right. I cannot project right now, but I think as we continue with the sessions, I'll be able to communicate to you as to when we'll finish exponents, then move on to equations and inequalities, then move on to nature of roots, then move on to trigonometry, and so forth. So, okay. You can see question 3. 3 to the power x plus 3 times 18 to the power x over 6 to the power x plus 1 times 9 to the power x plus 1. Okay. Repeat. 3 to the power x plus 3. Then there's a dot. 18 to the power x over 6 to the power x plus 1 dot, which means times 9 to the power x plus 1. So hopefully you are good. You're welcome. Makoma, done with 1 to 4. Good job, buddy. Good job. So are you one of those students that's been helping out in the group? The A students that they're talking about. These people that they are crying about and saying they are amazing students, those ones. King Seal is requesting. These people with 1K followers, more than 1K followers, they have this opportunity of being able to request to go live and join as guests. You guys see? It's banana 45. Schools are closed, Wena. And Wena, you are what? December. Oh man, banana. We don't want to become part of the banana republic, eh? Oh, it's 100 followers. Oh, so when you have 100 followers, you can join guests. That's fine. That's good. Okay, that's nice. Okay, even better, Moss. Even better. Give us calculus to solve. You are funny. Actually finished within 5 minutes, but failed within 16. Pressure. Opa, lakatic equations. Yes, grade 11. Oh, yeah. The comment section is always funny to read. That's fine, Makoma, you can do that. Mr. Administrator. Alright, guys. That's fine, hack 04. Go ahead, follow. See ya, that's great, you do that. Definitely nay, time's up. I was gonna say, you ran ahead of the game. Alright, let's go, guys. So back to the question. This question here has to do with multiplication and division, alright? Of numerical bases, there's only multiplication and division. Grade 11. Applicable to grade 10 exponents as well, but this is grade 11. So we need to change the composite bases that we see here to prime bases. How do we do that? If you have a scientific calculator, you can change the bases that you see are composite to prime by basically typing in the number, pressing equal, pressing shift, pressing fact. And then what happens is that your calculator will convert the 12 to your prime bases. So what you should then get, 12 can be written as 4 times 3. 4 is 2 squared times 3. Now 2 squared is 2 is a prime base, 3 is a prime base. 2 squared is 4. 4 times 3 is actually equal to 12. But then you put that in brackets, remember? And you write x minus 1 on the outside. 3 to the power 2x is already prime, so there's no need to do anything there. over, that's 6. But the 6, you say 6 is equal to shift fact, that becomes 2 times 3. All raised to what? 3x minus 1. So we've done the first step. What have we done? What have we done, guys? We've changed the composite bases to prime bases. Are we together? Are we together? Right, heck, thank you so much. Even the thought itself, it counts. The sentiment is very much appreciated. Okay. 2 to the power x. After we change composite bases to prime bases, we can now apply the distributive law. All right. 2 to the power x is retained. 2 to the power 2, 2 gets multiplied to x, 2 gets multiplied to negative 1. That gives us 2 to the power, 2 times x is 2x, 2 times negative 1 is negative 2. So base 2 now has 2x minus 2, all right? Don't forget to distribute the 2 to both terms outside the bracket. Then we do the same thing with 3. 3, we have a 1 there. 1 times x, 3 to the power x, 1 times negative 1, minus 1. Okay? Then we have this times 3 to the power 2x, so we add that 3 times 2 to the power x. Are we good? Are we good? The numerator, we sorted. Sweet. Then we go to the denominator. 2, same thing. There's a 1 there. 1 times 3x is 2 to the power 3x. 1 times negative 1 to the power negative 1. 2 is done. 3 also wants some. He's also hungry. We distribute. There's a 1 there. 3x, 1 times 3x is 3x. 1 times negative 1 is negative 1. So that's it. Okay. Now, after distributive law, then we collect the bases with their respective exponents using law number 1 and 2. So we have how many bases? We have base 2, which is 1, 2, 3. And then we have base 3, which is 1, 2, 3. So that means we're going to first collect all the base 2 exponents. Base 2 we have at the top. Okay. So bases have to be to the simplest. Yes, women of faith, you can see most what I've done, right? Okay. Now we have to collect the exponents. 2 to the power x. At the top, the sign remains as positive x. At the top, the signs remain. But when bases are the same and we are multiplying, what do we do to the exponents? We add them. So it's x plus 2x minus 2. Okay, we are adding 2x and minus 2 as they are. Then we go down. We have 2 to the power 3x minus 1 in the denominator. Now remember, whenever we come down, when we're taking this up to be added, what happens to the 3x? It changes sign. 3x becomes negative 3x. Then minus 1 becomes plus 1. Sign changes when we are moving up. Very important. In fact, when we are moving position from numerator to denominator, denominator to numerator, the signs of the exponent expression will change. 3x becomes negative 3x. Minus 1 becomes positive 1. Yeah, you can do that too as well, greatest op. It's just that I just do it once and for all for both bases. Just once and for all. Okay. Right. And then let's look at base 3. Now we collect for base 3 exponents. So 3 to the power at the top, x minus 1, that's fine. But then at the top, when bases are the same and we are multiplying, what do we do to the exponents? We add. So it was positive 2x, it stays as positive 2x. We come down. What do we see down here? We have 3 to the power 3x. So what happens to the exponent sign? 3x becomes negative 3x. Minus 1 becomes plus 1. Right? Then we are good to complete. Hey, Kamo Zizo. And you know what? I don't take myself as someone who is flawless. So what I do love is that when a learner does see that I've made an error, I love it when a learner is able to say, sir, and they raise their hand and respectfully say, sir, you made a mistake on that part. And then I can actually commend that learner for being able to identify my mistake. And I love it because if you can do that, if you can identify an error when I make it, it means that when you actually do the work, you're gonna do wonders. Okay, so there's no fear because I don't take myself that seriously in that sense. Okay, I'm imperfect. So here we go. Now we can add and subtract the like terms. Once we collect the exponents using law number 1 and 2, now we can add and subtract the exponents. So let's go. Base 2, what's x plus 2x? It's 3x. What's 3x minus 3x? It's 0. So the x leads us to 0. Let's look at the numbers. Minus 2 plus 1. What's negative 2 plus 1? That gives me negative 1. All right. Base 2 with its exponents, complete. Let's go to base 3. What's x plus 2x? It's 3x. What's 3x minus 3x? It's 0. So now we have 3 to the power 0. Then what's minus 1 plus 1? Minus 1 plus 1 is 0. So we add 0. Then finally we have 2 to the power negative 1 times 3 to the power 0. 2 to the power negative 1 is simply a half. And then 3 to the power 0 is simply 1. What's half times 1? The answer is a half. Okay. Okay. All right. Women of faith, I got the answer, but my bases weren't on the simplest. Is it still correct? Or if you got the answer and your bases went the simplest, it should still be fine. Okay. All right. Maybe what you can do for me is that when I do come into that group, if Women of Faith is already in the group, or maybe when you can actually take a picture of your problem, how you solved it, and you can send it to me as a picture in the TikTok DM. Just send me a message on TikTok. Just take a picture of your work that you did, send it to me as a message on TikTok when you are done, and then I can just look over it to just verify and check that it's spot on. Okay. So what I love is that we don't necessarily have to, we can get to the answer, but not necessarily in the same way, as long as we are able to get to the answer and our steps are actually correct. Given Jan, you said you got negative half. My question is how? How did you get negative half when there is no negative sign anywhere in sight? Okay. So it can't be that you got negative half because there's no negative sign for your bases anywhere in sight. This base 2 was positive. This base 12 was positive. The 3 was positive. The 6 was positive. There's no way where we have a sign of a base that is negative. The only way you would have gotten a negative sign or negative answer is if the bases, one of them were negative. Okay, so the answer is half. Okay. All right, hopefully we are on the same page. All right. Okay, let's move on. Question number 2. 4 to the power x times 2 to the power x minus 2 over 8 to the power x minus 1. So same thing, what do we notice? The relationship between the bases is multiply and divide. 4 times 2 divided by 8. So there's no addition or subtraction. Once again, the relationship is multiply and divide. So what does that mean? Step 1, change all the bases that are composite to prime. Okay, no problem, Jen. You do that. You can even send me a DM. Okay, yeah. No, 0 plus 0 is not 1. No, you can't say 0 plus 0 is 1. 0 plus 0 is 0, guys. Okay, 0 plus 0 is 0, and then 3 to the power 0 is equal to 1. Okay, please. Okay, Very important. Yeah. So we change 4 into a prime base. That's 2 to the power 2. We put it in brackets. We put the x on the outside. 2 is already prime base with x minus 2, no problem. 8 is 2 to the power 3. And then we write the x minus 1 next door. Okay. Unknown Inza, I am so relaxed, it's not even funny. We are so relaxed, it's not even funny. Just relaxing with some maths before we sleep. You know what I mean? Then 2 times x, grade 11. 2 to the power, now we distribute 2 to the power 2x, 2 to the power x minus 2, over 3 times x, 2 to the power 3x, 3 times negative minus 1 is minus 3. Alright, then move on to the next step. We collect bases with their exponents, but what we can see is that the base here is only 2, so we are just dealing with base 2. So what we can simply do is we can say base 2, then collect the bases. 2x is in the numerator, so it's positive. Everything at the top remains with the sign that it has. This is plus x, this is minus 2. Then when we go down, remember, 3x becomes negative 3x and minus 3 becomes positive 3. As we go down, our sign changes. Final answer, as we conclude, 2 to the power, what's 2x plus x? It's 3x. What's 3x minus 3? It's 0. Then that's minus 2 plus 3. It's plus 1. Final answer, 2 to the power 0 plus 1, it's 1. And the answer is 2. Very good. Very good. Bunzy boy. Bunzy boy. Look at you crying all sorts of tears. Right. I don't want people crying next year here because they did not get level 7 for grade 11 maths when they should have. And they want to apply for medicine and they have level 4 or level 3 and come next 2026 in April when they apply in grade 12 and they can't apply, they have to wait for September or June in their grade 12 in order to improve their results. I want it to be a possibility next year. Okay, so let's do this, guys. Let's do this. That's why we're doing what we're doing. There's reasons why we're doing what we're doing. We're not doing it. We know that doctors, they get called like in December to go and work. They work crazy awkward hours. So you know what I mean? Okay, anyways, let's move on. Number 3. 3 to the power x plus 3. Okay, let's go, guys. Let's go. Same thing. What do we see here? Bases. No problem. And if your method is very short, please, all of those things, do share them with me. I did like to approve, you know. Remember, I'm just applying a general common method, but like I said, this is not the be-all, the only method, but, you know, some of you may be, obviously, you know, that's fine. Okay, so let's see. Base 3 to the power x plus 3 times 18 to the power x over 6 to the power x plus 1 times 9 to the power x plus 1. So the relationship between these bases is multiply and divide. So once again, we have multiply and divide, so we know what to do. Change all composite bases to prime. So this is already prime. 18 is 3 to the power 2 times 2. We put the x on the outside, all right, in brackets. 6 is 3 times 2. We put the x plus 1 on the outside. Okay. Guys, don't worry, man. Don't worry about these people that are requesting all these other topics. We have a program that we are going by, and it's the ATP that's informing what we are doing. So don't worry, don't stress about all these people having funny requests. All right. For now, we are sticking to the program, Exponents and Surds, and we will go through it until it's finished. We'll run the course as it should be. Okay, let's take it one step at a time. We should be good. Okay. So we change 9 to 3 to the power 2. We have x plus 1 on the outside. Then we have 3 to the power x plus 3. Then we distribute 3 to the power 2 times x, 3 to the power 2x. 2 to the power x. Make sense? Over 3, distribute as well. 3 to the power, there's a 1 there, 1x plus 1. 2 to the power x plus 1. Alright. You have some 3x plus 1. You have some 2x plus 1. Times 3 to the power 2. 2 gets distributed, 2 times x, 3 to the power 2x. 2 times 1 plus 2. Okay. Bruce Wayne, I love you, but you need to change your mindset, because your mindset of resting will lead to a lot of distraction for some of these kids that are here. So allow us to continue, and you can leave the live, please. All right. Then what do we do now? We collect the bases. Okay. No problem. Let's really ignore them. Base 3. All right. Let's collect the exponents. X plus 3. The top plus 2x, base 3. The bottom minus x. The bottom minus 1. You see the sign changing. The bottom minus 2x. The bottom minus 2. Okay. Makes sense? Because we have base 3, 1, 2, 3, 4. So we wrote 3 to the power x plus 3. That's fine. Plus 2x. That's fine. We go down. We minus x. We minus 1. Because the signs change. Minus x, we minus 1. Then here, we minus 2x, we minus 2. Okay? Alright? Then, we collect base 2 now. We collected base 3 first, alright? It doesn't really matter which one we collect, because remember, the order of multiplication doesn't matter. When we say, whether we say 3 times 2 or 2 times 3 doesn't matter. Let's move on now to base 2. Base 2. We collect x, it's at the top, so the sign is as it is. But the minute we go down, the signs change. X, negative x. Plus 1 becomes negative 1. Okay. Let's complete and finish now. Base 3. What's x plus 2x? It's 3x. What's 3x minus x? It's 2x. What's 2x minus 2x? It's 0. So we have 3 to the power 0. That's for our x terms. Then let's take the numerical terms. 3 minus 1. What's 3 minus 1? It's 2. What's 2 minus 2? It's 0. So we have 0 plus 0. Then times 2. We have 2. What's x minus x? That's 0. Then minus 1, minus 1. Okay. Now what's 0 plus 0 for the base 3? It's 3 to the power 0. What's 0 minus 1? It's 2 to the power negative 1. Makes sense? Then final answer. What's 3 to the power 0? It's 1. What's 2 to the power negative 1? It's a half. What's 1 times half? It's a half. So the answer is half. Bokamoso, you got 3 over 2. I wonder how. Grade 11, guys. Grade 11. Alright. If you guys look at my steps, step by step, we did what needed to be done. Alright. And we applied the right. You got 1 over 18. Now you need to go back and check what is it that you slipped up in doing. Remember, 3 to the power x plus 3 stays the same. Okay, Queen Sogutela, don't be chafarized. It's no problem. Okay, it happens. But we need to just retrace your steps and look what you did. Okay, let's look at it one more time. 3 to the power x plus 3. 18 can be written as 3 to the power 2 times 2. The x is on the outside. 6 can be written as 3 times 2, x plus 1 on the outside. 9 can be written as 3 to the power 2 with x plus 1 on the outside. Okay, makes sense? I don't do physics, I do maths only in this channel, all right? Then 3 to the power x plus 3 is fine. We distribute. What's 2 times x? 2x. Then 2, that's 2 to the power x. Make sense? We're good at the top. Go to the bottom. 3, I get some x plus 1 for 3. 2, I get some. It's x plus 1 for 2. Done. Move on to 3 to the power 2. 2 times x is 2x. 2 times 1 is 2. Okay? So this year, 100% correct so far. I know it because I can see my maths. It's 100% correct. Look at yours. Was there any mistake you may have done here? Something that went wrong? Did you get 2x plus 2 as well for this particular base and its exponent? Okay. All right. Then we move on. You collect the bases. Base 3, x plus 3, that's x plus 3 in the numerator. That's fine. The signs don't change. Plus 2x in the numerator, it's plus 2x. We are good. All right. Then we go to the next base 3. It's in the denominator. What happens to the signs of the exponents? They change. X becomes negative x. Plus 1 becomes negative 1. All right. Then we move on to the other base 3. 2x is positive, but it becomes negative 2x. Plus 2 becomes negative 2. So this here, base 3, we should have the signs of these exponents this way. Okay. Okay. So far are we good? Hopefully we are good. All right. Hopefully we are good. Then base 2. We collect base 2 exponents. For this one, we have to the power x that's positive at the top. Then when we go down, the x becomes negative. The 1 that's positive becomes negative. Where did you make the mistake, Queen Sokodel? Do you see where you made the mistake? Okay, as long as you see where you made the mistake, that's important. Then you add the like terms. Now my addition of like terms was on point. Okay, very much on point. So x plus 2x is 3x. 3x minus x is 2x. 2x minus 2x is 0. That's why I got that 0 from. 3 minus 1 is 2. 2 minus 2 is 0. So I have 0 here. 0 plus 0 gives me 0. 3 to the power 0 is 1. Okay. Why do we change the sign for the denominator bases? It's because, remember, we have a law that says whenever you are dividing same bases, you keep the base and you subtract the exponents. So this is like saying 3 to the power x plus 3, but then we say minus. Remember that minus sign must apply for both the terms that are this binomial. So it should be minus x minus 1. All right. 3 to the power x plus 3 minus x minus 1. The signs change for the bases and their exponents. The signs then change. Okay. So please, it's very important that you note that. That's why the signs change. They change for all denominator bases. The signs must change. All right. Right? Because we are applying law number 2 of exponents. Then this side, what's x minus x is 0. Then negative 1 is there, negative 1. 0 minus 1 gives you negative half. What's 2 to the power negative half? We can write 2 to the power negative half as a positive exponent, which is 1 over 2. What's 1 times half? It's half. So that's how we got our answer. Okay. Okay. Right. Then last but not least, I want you guys to take note of the step that seems to give you the most problem. Then you need to make sure that that step, you do not make any further mistakes where that step is concerned. Okay. This is the last question that we are going to do for the night. Then I'm going to call it a night for today. All right. Then, guys, we will have a session tomorrow again. Same time, same place, same people, same agenda. All right. Yeah, and Makom will definitely be swinging over that digit so that you can actually add me in that group. Okay. Bruce Wayne, we have a program that we are following here, so yeah, we are not going to be jumping to any other topic until we have completed this one. Okay, so first step, check the question. What type of question is this? It's got multiplication and division of bases again. So this is an M and D question, which means we need to first convert all composite bases to prime bases. I think Uzuita is getting it. Okay, very good. So that's what we do whenever we see that there is multiplication and division of numerical bases that are different. So 5 is already prime, so that is sorted. 9 is not prime, but if we use our calculator, we say 9 is equal to shift fact, we get 3 to the power 2. All right, I mean, we should know that off by heart as well. You guys you remember this letter method that you guys did back when you were in grade 8 or grade 9? That was helping you to write all composite bases to prime bases as a product of their exponents. I think you remember that. You guys would identify the prime numbers, the smallest prime numbers that go into this number. You'd say 3 goes into 9, how many times? 3 times. Then you'd ask yourself, what other prime number goes into 3? 3 goes into how many times? Once. Once you get to 1, you stop, and then you say 9 is equal to 3 times 3, which in other words is 3 to the power 2. This is what we call converting a composite number to prime. Okay, yeah. So let's go on. This 9 is 3 to the power 2. You write it in brackets, x plus 1 on the outside. These brackets are important, please guys, don't forget that. Then 3 to the power x plus 2 times 15. This is already prime. 15 is 5 times 3. And then you write the x minus 1 on the outside. Now let's finish off. We apply the distributive law. 2 times x, 2 times 1. 2x plus 2. Alright? Over 3 to the power x plus 2 times. Now 5. 5 needs to get some, then 3 needs to also get some. Remember that there's a 1 and a 1 there, so we say 5 to the power, we distribute that 1, x minus 1, and 3 to the power, x minus 1. They both get some. Alright? Yeah. Then we can now collect the exponents. Base 5 and base 3 are the only bases here. Okay, keep the base at the exponents for the ones in the top, but then for the ones at the bottom, we change the signs. So 5 to the power x is the only base that's in the numerator. So x, then we go to the bottom. There's 5 to the power x minus 1. It's the only one in the denominator, so that means the signs will change for the terms. So x becomes negative x. Minus 1 becomes positive 1. Make sense? Because this is like taking these upstairs, but when we take them upstairs, what happens? The signs change, right? Then we go to base 3. 3 to the power, at the top we have 3 to the power 2x plus 2. Okay. Then at the bottom we have 3 to the power x plus 2, and we have 3 to the power x minus 1. But when we go down, what happens? The signs change. This x becomes negative x. This plus 2 becomes negative 2. Then here we have another x minus 1. It's at the denominator. What happens to this x? Becomes negative x. What happens to this negative 1? Becomes positive 1. Okay. Then we finish off by adding the like terms for the exponents. Let's go. What's x minus x? It's 0. What's plus 1? 0 plus 1, which is 5 to the power 1. Base 5, complete. Let's go to base 3. 2x minus x is x. What's x minus x? 0. 3 to the power 0. Go to the numbers. What's 2 plus 1? 2 plus 1, 2 minus 2, first and foremost. 2 minus 2 is 0, plus 1 is 1. What's 0 plus 1? That's 3 to the power 1. What is this? 5 times 3. What's 5 times 3? 15. Where are you struggling? What is the problem? No, don't be disappointed in yourself, woman of faith. Keep your head up. Just identify where the problem is, right? Okay, as maths learners, that's the skill we need to actually adopt as maths learners. We need to stop being discouraged by the fact that we didn't get everything correct. A mistake or an error is an opportunity to exploit that error and change it to be something that actually will work together for your good. Once you realize there's a problem, you can actually zoom into the problem, identify it, work on it, and then become better because of that error or that failure or that mistake. So don't be disheartened when you make an error. I think that's that's something we do wrong as learners that are doing maths, and maybe even as teachers. That's something that we actually do wrong by you guys, because we seem to really be on this tip of everybody needs to get things right. But when you do make an error, you need to check what's the problem. So for instance, are you having a problem with converting composite bases to prime bases? If that is your problem, then remember I said to you, to convert composite bases to prime bases, you simply take your calculator, you write down the number. So you'd say 9, you write down the number, then you'd write equal in your calculator, press shift, press fact. The calculator will give you the answer. You'll get 3 to the power what? 2. Alright, does that make sense? Then you write it in brackets. The minute you get that answer, you write it in brackets. Then you keep that exponent expression on the outside. Okay. Secondly, if it's not converting composite bases to prime bases, is it the distribution that is a problem? 2 times x, 2x, 2 times 1, 2. Alright? Are you having a problem with the distribution law? Okay. Alright? I hope that makes sense. Then, if that is not the problem, could it be that you are having a problem with your collection of exponents? Because I've been saying to you guys, and I'm going to repeat this again, that whenever you are collecting the bases, what is in the denominator retains its sign. So for instance, I first wrote 5 to the power x when I collected the base 5. 5 to the power x is in the numerator. Its exponent is positive, it will stay positive. It's positive x. Base 5 for the other base that I have for base 5 is in the denominator. The exponents, when I write them down here, will change. The x was positive, but when I actually now add or subtract it to this particular exponent, it will become negative x. Alright, and then also this minus 1 will become positive 1. This is a direct application of law number 2 of exponents. I just want to probably just do this for you. Maybe let me just for clarity's sake. Okay, if you have 5 to the power x and it's divided by 5 to the power x minus 1, this is the practical thing here. We're saying that when bases are the same and we are dividing, we keep the base, we subtract the exponents. So this 5 to the power x is in the numerator. So we write down 5 to the power x, but then we would say minus this x minus 1, which is a binomial, which would be x minus 1 in brackets. Alright, but practically speaking, this minus 1 is distributed to this binomial. That becomes minus x. This negative times a negative gives us a positive 1. So this is what we actually have as an expression to actually add and subtract. And then we would basically go ahead after that and add and subtract the like terms. Okay, so this is like 5 to the power x at the top minus the expression, which is a binomial, so we put it in brackets. Minus into x gives us minus x. Minus into minus 1 gives us positive 1. But you guys are seeing me say to you, I am just simply saying to you, to make life easy, you don't have to put this minus and put the bracket. You can simply just take it in this fashion, that you simply do this. You write this 5 to the power x, it's positive, it's in the numerator. These are in the denominator. The signs of the expression will change. This x, which was positive, becomes negative. This minus 1, which was negative, becomes positive. Right? So every time you have something in the denominator, the sign of each term in your exponent changes the minute you actually write it here. X is not positive anymore, it's negative. Minus 1 is not negative anymore, it's positive. Okay, and then same thing here with the 3 when you connect the 3. Okay, so yes, yeah. So guys, I think that's where we need to that's what we need to do. We need to identify where we are going wrong. Okay, Banile Makai, respectfully, you're dragging the whole thing. All right, that's fine. Okay, guys, I think I'm gonna hold it right there. Okay, that was that example. Thank you very much for joining the live. Makoma, I will be contacting you on the side. You can send me actually a message and just let me know what's happening. Okay, so we'll be going live again tomorrow around about the same time. So I think 8:30 is kind of like the time. 8, 8:30, 9, all right. Then I will post whatever other exercises that are similar to this. I will post them onto the TikTok page again as slides, and then also I will send those through to your group. Okay. So let's just say tomorrow we'll have the session again at 8:30. Let's agree on 8:30. 8:30 for 9. Okay, 8:30 for 9 p.m. We'll see each other then. Then we can continue where we left off. But guys, yes, all right. I think for those that were here, the homework, I will be posting it, like I said, on the TikTok page. I'll post it as slideshows, okay, picture slides, all right? Yeah. Okay, guys, thank you very much. Yeah, let's see each other. Yes, and please, guys, I like the fact that people are mentioning other people. Mlungi Sinkos is amazing. There's lots of physical science, maths teachers. Please don't limit yourself. Don't limit yourself even to this particular channel. There's other platforms where you can learn maths. There's Kevin Maths and Science. There's many people, okay, that you can actually check up. But yeah. 8:30 for 9, okay, tomorrow, 8:30 for 9, 8:30 for 9 p.m., 8:30 for 9, yeah, all right, guys, thank you so much. I unfortunately just do the maths, no life science and no physical science, so unfortunately, all right, and then like I said, I'll be posting the maths, what you could say exercises, just for you guys to actually practice some more these types of questions that we did today, all right? But thank you so much. Have a good night. Definitely, I'll be live next year. I'll be live January, February, March, April, May, June, July, August, September, October, November, December. I guess I could say I'll be the new uncle on TikTok, if you will. That's fine, Zita. That's perfect. If you being a maths tutor yourself and you're here pretending to be a learner, that's perfectly fine. I learn a lot from a lot of people. I do not claim to be the be-all and end-all of maths. I just am trying to do what I can do in my own space. So if you're a tutor and you're joining in, maybe you can actually do more yourself in your own space, and maybe you can do maths lives and help other people. You are Mr. Who? No, will not be disclosing that information. For now, we can just. It's fine. Just me being Maths is a Game, just representing the brand Maths is a Game. Please, guys, also do subscribe to the YouTube channel. It's also called Maths is a Game. So for those who may have probably not tuned into previous lessons, you can go on there. It's pretty raw, as you can see. It's the raw lessons as you see them. Yeah, it's raw as you see them, guys. There's no edits, no nothing. It's just the raw lessons. So do what you can, learn what you can. Anything that will help you progress and improve. Okay. Yes, I said I'll be live in January, February, March, April, May, June, July, August, September, October, November, December. Next year it will be the whole way through. Pre-exams, after exams, before exams, syllabus-wise, the works. All right. Yes. Yes, December, man. December. You reap what you sow, eh? You reap what you sow. That's my belief. But guys, thank you so much. Have a good night. Rest well. And yeah, practice, and do the stuff. There's a WhatsApp channel, Maths is a Game, as well, that you can check out. Maths channel. It's on WhatsApp. Maths is a Game. Everything is Maths is a Game. It's a WhatsApp channel, Maths is a Game. It's a YouTube channel, Maths is a Game. It's TikTok, Maths is a Game. Yeah, everything is Maths is a Game. All right. 11 tomorrow, guys. I said we're doing grade 11 tomorrow at 8:30 for 9. All right, 8:30 for 9. Doing grade 9 and 10 in the morning at 7 a.m. Okay. Doing grade 9 and 10 at 7 a.m. tomorrow morning. Then grade 11 will be doing it at 8:30 for 9 tomorrow in the evening. 7 a.m. grade 10 and 9. 7 a.m. grade 9 and 10. 7 a.m. grade 9 and 10, and then of course can go 8:30 for 9. That will be grade 11. Okay, thank you guys again. Have a good one, and thanks so much. Cheers. You guys.